Good morning, student. Today, I'm going to give an introduction about DNS, domain name system in the internet. In internet, several systems are connected. So DNS is mainly used to convert a domain name name into IP address and IP address into domain name. So this topic, we are going to give a small introduction about what is DNS, what are the types of DNS, and resolution and all. In a OSI networking layer, there are several protocols available, TCP/IP, UDP, SNMP, ICMP, and all. So TCP/IP protocol uses IP addresses mainly for addressing a particular PC in the internet, which is used to identify connection of a host to the internet. So we need a mechanism which maps name to an IP address. So each IP address has a two column, the particular machine name and the address, which is used to uniquely identify a particular system in the internet. So what is DNS? DNS is a domain name system, which is nothing but a phone book of internet. Human access information online through domain names like SRMIST.edu or nighttimes.com, amazon.com, etc. Generally, web browser interacts through the internet protocol addresses. So this DNS system translates domain names to IP addresses. So the browser can load the internet resources accordingly. There are 6 steps we have to follow to map the host name to the IP address. First, the user passes the host name to the file transfer client. File transfer client passes the host name to the DNS client. DNS client sends the messages to the DNS server, which contains the query, gives the file server name using the known IP address of the DNS server. Then the DNS server responds back with the IP address of the desired FT server. So after receiving the responses, the DNS client passes the IP address to the file transfer server. So this file transfer client uses that IP addresses to receive the particular services from the file transfer server. So these are the 6 steps we should follow to map the host name to the IP addresses. Example, a person at wonderful.com. So wonderful.com is a host name which is forwarded to the DNS client. That is further forwarded that query request message to the DNS client. Accordingly, the DNS server convert this host name into particular IP address, which are redirected back to the client. In general, namespace is nothing but to be an unambiguous. The names assigned to machine must be carefully selected from the namespace, which has a complete control over the binding between name and IP addresses. So this namespace maps the address to the unique name, which are organized into 2 different mechanisms: flat namespace and hierarchical namespace. Flat namespace means name is assigned to an address, which is a sequence of character without any proper structure. It is applicable for a small representation, small system representation. It cannot be used for a very big type of a system. Centrally controlled to avoid ambiguity and duplication. Then the second type is hierarchical namespace. Each name is made up of several parts. First part, nature of the organization. Second part, name of the organization. Third part, departments in the organization. And namespace can be a decentralized one. Suffixes are added to the name that defines the host. Domain namespace is a hierarchical namespace. Names are defined in inverted tree structure with root at the top. A tree has 128 levels of 128 levels. Root 0 to 127 leaf. Label: each node in a tree has a label, maximum of 63 character. Root label is null string. Child nodes should have a different labels, which ensures the uniqueness in your domain name system. Domain name, full domain name is the sequence of labels is separated by dot. For example, srmist.edu.in. So the domain names read from nodes to the root node. These are the hierarchical structure representation of domain name system. In general, Domain name system can be classified into fully qualified domain name and partially qualified domain name. In fully qualified domain name, if the label is terminated by null string, it is called a fully qualified domain name. It contains the full name of the host, contains all the labels from most specific to most general. DNS server can match a fully qualified domain name to the particular address. For example, challenger.atc.fhda.edu. This is a fully qualified domain name. From leaf node, root node to till the host, all the representations are properly defined. Partially qualified domain name, if the label is not terminated by null string, it is called partially qualified domain name. Partially qualified domain name start from the node but does not reach to the root. So the solver I'll teach you later. What it will do, it will supply the missing part in your DNS representation to create a partially qualified domain name. For example, user at fhda.edu site wants to get the IP address of the challenger computer, has to be mentioned in partial name like challenger. So what the DNS client will add a suffix of after using this text, it can consider act.fhda.edu. Domain name system. Domain is nothing but it is the subtree of the domain name space. The domain is the name of the node at the top of the subtree. Domains may further divided into subdomain. Information in the namespace are represented in a tree structured manner. It is inefficient and not reliable to store the information in a single system. Hierarchical namespace divide the whole space into several notation, root level, child level, and leaf level, etc. Zone, what a server is responsible for or has authority over is called zone. Is a contiguous part of the entire tree. If the server accepts responsibility for a domain and does not divide the domain into further smaller domain, we call that as a zone. Root server, it is nothing but it is the server whose zone consisting of the whole tree structure. It does not store any information about the domain, but it delegates the authority to the other server. Domain namespace may be a primary, may use a primary server or secondary server. Primary server, the server stores the file about the zone for which it is authority. It is the main part for creating, maintaining, and updating the zone file, which are maintained in a local disk. Secondary server that transfer the complete information about a particular zone from another server and store the file on its local disk. This secondary server creates or nor updates the zone file. This is the DNS three types: generic DNS, inverse DNS, and country domain. Generic domain define the registered host according to their generic behavior. Each node in the tree defines the domain, which is indexed to the domain namespace database. Generic chal.atc.fhda.edu. Index to from the label part to root node, all the domain subdomains are represented. In general, the label arrow denotes the airline or aerospace companies, design business or firms, commercial organization, cooperative business organization, EDU for educational institutions, GOV for government institutions. These are some of the generic domain labels used in website. Then country domain uses normally 2-character country abbreviation, US for United States, UK for United Kingdom, like that. Second label may be organization, or they can be more specific nation or designations. Inverse domain, it is used to map an address to a name. This happens when the server has received a request from the client. Type a query called an inverse or pointer query. To handle the pointer query, the inverse domain is added to the domain namespace. Then these are about the DNS introduction. Next, resolution. We are going to map a name to an address or address to a name. Okay, which is done by means of name address resolution. For that, we are using the component resolver. DNS is designed as a client server application. host that needs to map an address to a name or name to an address is called as a DNS client, called as a resolver. We need this resolver in order to convert the DNS mapping domain name into address or vice versa. After the resolver receives the mapping, it interprets the response to see if it is resolved correctly or not. If any error is happening, then the particular error message is delivered. Mapping names to an address, the resolver gives domain name to the server and asks for the corresponding address. If the domain name is from the generic domain, the resolver receives the domain name such as chal.atc.fnda.edu. If the domain name is from the country, then the particular country name is added at the end. Mapping address to a name, the client can send an IP address to the server to be mapped to a domain name. To answer the PTR query, the DNS system uses an inverse domain. In the request, the IP address is reserved and two labels in address and ARP are appended to create a domain acceptable by the inverse domain. Recursive resolution, the client can ask for a recursive answer from the name server. If the server is the authority for the domain name, it checks its database and responds. If the server is not the authority, it sends the request to the another server and wait for the response. Iterative resolution. If the server is the authority for the name, it sends the answer. If not, it returns the IP address of the server that think it can resolve the query. The client is responsible for repeating the request to the second server. The client repeats the same procedure to the next server and so on. This process is called iterative process. Once a particular request is coming, that is forwarded to the DNS server, then the response is generated. That process is repeated until the client accepts all the query responses. Catching, each time the server receives the query for the name that is not in domain, it needs to search its database for a server IP address. So reduction in search time would increase the efficiency by means of catching mechanism. So reduction of the search time would increase the efficiency. So DNS handles this situation and increase the efficiency of a system using catching technique. By means of this catching technique, the resolution can be increased. The server catches the mapping for a long time. It may send an outdated mapping to the client. Two techniques are used. The authoritative server always adds information to the mapping called time to live. DNS requires each server keeps time to live counter for each mapping it calls. DNS messages are two types, query and response. The query has the header and the question records. The response message consists of a header, answer section, authority section, additional section, and all. This is a representation of a header and the corresponding field format. Both the query and response message have the same header format with the sum field set to 0 for query message. The header is of 12 bytes. Identification 16-bit field used by the client to match the response. A flag of 16-bit field consisting of the subfield. Query response 1-bit subfield defines the type of message. 0 message is query, 1 for message is response. Opcode 4 bits define the type of the opcode. 0 for standard, 1 for inverse, and 2 for server starts request. And authoritative answer 1-bit subfield set to 1. The name server is the authoritative server used only in response message. TC for truncate 1-bit subfield set to 1. Response for 512 bytes and truncated. It is used when DNS uses the services of UDP. Recursive decide RD 1-bit subfield set to 1. Client desires a recursive answer. It is set in query message and repeated in the response message. And RA recursive available, which is a 1-bit subfield. Set in response means that the records are available. Set only in response message. Similarly, other fields also represented. Reserved bit 3-bit subfield set to 000. R code 4-bit field shows the status of error in response messages. Then the number of question records 16-bit field, number of answer records 16-bit field. All others are 16-bit fields, authoritative records, additional records, and all. DNS messages has a several subfield question section consist of 1 or more question records. It has both a query request and response message. Answer section, it consists of 2 or more record. It is present only on the response message. And the authoritative section, additional information section. So that's all about the DNS introduction. Any doubt, a student can ask. Thank you.